Memory and process sensitive software. This will be given in the next table. So now we are going to see the allocation of address to memory, program segment and device. So how the addresses are allocated in the memory, how the segments, program segment, that is your entire program will have certain different segment. Okay, so that's a different segment, otherwise we can call it as a module. Okay, program modules. So each program module will be stored in a different memory space, okay, or location. So that will be given in this topic. So program routines and process can have different segment. For example, a program code can be segmented and each segment stored at a different memory block. A pointer points to the start of the memory block storing a segment, and an offset value is used to retrieve a memory address within the segment. Okay, this is nothing but, so the entire program will have different module or segment. So each segment will be stored in a different memory block. So pointer will be used for indicating the address of your memory block for this segment, particular segment. And offset value, the offset value also one of the type of address which will be used for retrieving the memory address from the segment. Okay, then here the different segment at the memory will be used for different functions and process, that is threads or task. The different segment which is used for data and different segment for stack will be having a starting memory address and ending memory address. Okay, so each segment which is stored in memory location will be having starting address and ending address. Okay, pointer will point out the address of your memory. Okay, next address of your memory. And then there can be different sets and different structure of data at the memory. Following are the examples of data structure and data set that are commonly used during processing in a system and that are stored at the different memory blocks in a system. So few examples are given, that is nothing but stack. For example, stack is a special type of memory which will be working similar to left in first out or first in last out. Okay, so first entered data will be read out lastly. Okay, this is the concept of stack memory. So here stack will be used for storing the program address as well as data. Okay, this is hardware sensitive programming. Here you will be having two types, that is process sensitive and memory sensitive. So in process sensitive type, you will be using input output instruction. That is input output instruction where you will be using means for transferring the data or receiving the data or address through the port, input output port. In that space, you will be using input output instruction. So first one, I think you all studied in your microprocessor, that is the type of interfacing with the input output port is memory mapped input output mapped input output. This is the two types of fetching method, okay, decoding techniques which is available for interfacing the input output ports with the microprocessor. Okay, so there you will be using input output instruction, that is in 08, because you will be using only 8 bit. Okay, you'll be having 16-bit processor but 8-bit only available for input output ports. So in 08h, like that you'll be using instruction. For example, I'm saying so that type of instruction will be used for executing the program. Okay, that type will come under the process sensitive. Okay, you, so here the processor will have fixed point ALU only. Fixed point means it will not be working for or do the operation of floating point. Okay, that point, after that point for numerical value integers. Okay, for example 418.206 and the point kapra ulla value will not be operated by the this type of executing method. Okay, so here you'll be using only the floating point operation, but a special case of processor may execute the floating point operations, but single instruction multiple data and then very large instruction word, these two processor will not execute the floating point operations. Okay, maximum you will be designing the program with assembly language. Okay, what is assembly language? Man known language, move, add, sub, this will be called as the assembly language programming. The next, memory sensitive type. So under this you can have the example of video processing and real time video processing. Okay, so here each and every module will be important for the uh, video processing. Okay, because each and every pixel will give produce a clear picture. Okay, that's why it's very important for each and every module of the program is important for video processing. So see here, to get the picture resolution, clear picture, that is picture resolution, quality of the picture will be defined by the term resolution. Okay, so the picture resolution actually used for processing a number of frames processed per second will depend on the memory available as well as the processor performance. So based on the processor and memory usage, your picture or your frames will be processed for a second. ஒரு செகண்ட்ல how many frames can be processed, that will be depend upon the memories and processor used in the system. Okay, embedded system. If a large memory is available, the solution will be higher. Okay, if the memory is very low, then the resolution will not be clear. Okay, it will be having low resolution. Okay, that is, it will not have quality picture. Okay, so to get the higher resolution picture, you have to have higher memories as well as processor performance could be very good or effective. Okay, the next point, memory address of input output device register, buffer control register and vector address for the interrupt source or source group are prefixed in a microcontroller. So for having storing the memory address, you will be using all these types of devices or blocks in the microcontroller. Okay, so all these devices will be programmed and then it will be considered in the into the account. Okay, and the next, when using certain instruction set like thumb in ARM processor helps 16-bit instruction. So ARM processor you will be accessing and processing the data for 16-bit. Okay, but why we are doing 16-bit means to avoid the memories or to save the memory space, because ARM processor will hold 32 bits, but there we are going to use only 16-bit instruction to save the memory. Okay, further data set which is used for allocation of memory is given here. I think you all know what is string. String is nothing but group of characters. Okay, ASCII character will come under the string. And then circular queue, circular queue is nothing but for example in the program you will be routine program, subroutine program, you will be saying subroutine program, a program or a module will be called often in the main program. Okay, for example if you want to do any process repeatedly, then you will be using that module for the program, you will be calling that program by using the instruction call, like that. Okay, jump, etc. So this will be coming under circular queue. And then one dimensional array. So one dimensional array, this structure array will be having array, one dimensional array. So the first element of the other array will be always pointing out the address. Okay, the next, table. Table means two dimensional array. Two dimensional array means you will be having row and columns. Okay, and then hash table, this is a memory block. Here you will be having key, pair of keys. Okay, and their corresponding value which will be kept in column and rows only. And then lookup table. So lookup table also will have column which will be storing the pointer value, that is the address value, this will be the first column of the table will be used for pointer to get the value, and then list. Finally, list. This is the allotted memory for a data structure. Okay, here you will be storing a pointer to the next element at list. So it has one memory block allotted to each of its element. The list top pointer points to its first element and the last element points to null. Okay, so the in the list the first element will be pointing out the pointer address, and then last element will be pointed to 0. Okay, that is null. Okay, that's all this topic.